Hey there guys, welcome back. Got another video here with Mr. B, and hope you enjoyed the last one on percentages, fractions and decimals. Hope you had a chance to have a go at the challenges that we set up on the class web page. If not, please go ahead and do that because it's important for your learning and it would really reassure me to see how well you guys are doing. But we're moving on today with a new subject and a new slide. This one is all about identifying 3D shapes. You can recognize some of the ones going on here on this page. We have things like triangular prisms, we've got pyramids, square-based pyramids, we've got spheres, and we've got the two that we are focusing on today, which are the cube and the cuboid. Think about what's the same and what's different between those, because I'm going to ask you that later. Before I do that though, we need to cover some of the vocabulary that's going to be popping up in this presentation. So, when we hear 3D, we also think about 2D shapes, and we need to realise that there is a big difference between the two. With 2D shapes, you obviously have only two dimensions, okay? When we think about these common 2D shapes, like squares and rectangles, we think about the length and the width of these two different shapes here, okay? But if it's two-dimensional, we need to just remember that that means it's a very flat shape. In fact, it's a perfectly flat plane. You can flip it over and it will still be the same, but that's kind of the only way you can look at it, really. Whereas in a 3D shape, you've got more than that. You've got the height, width, and the length, okay? 3 dimensions there. Now, the thing about 3D shape is that it's easier to pick up, and you can look at it from lots of different ways. But there are parts of those shapes that we need to understand and be able to recognize and talk about in a very mathematical way. Alright, so obviously you have the edges of these shapes, okay, pretty self-explanatory. But where those edges meet, you might think, okay, that's called a corner. Well, actually in maths, it's not called a corner necessarily. For a 3D shape, it's called a vertex, where 3 or more edges meet, okay? And then you have to change that word into its plural form when you're talking about more than one vertex, okay? It becomes a set of vertices, and in a cube, for instance, you have 1, 2, 3, 4, 5, 6, 7, 8 vertices. And you'll see later on that a cube actually also has 8 vertices as well. Now, between all of those edges and vertices is a flat surface that we call the face of a shape. And think about what everyday item you might see that is actually a cube. Think about what you use in games. Hopefully you've thought of a dice. Okay, a dice is a cube. And what's the highest number you can get on a dice? It's 6, and that's because there are only 6 faces on a cube. Alright, and again, that's another similarity you might be able to spot within a cuboid. So, hopefully that's all cleared up for you now. Let's think about now what's the same and what's different between these two shapes. So we recognize that this is the cube and this is a cuboid. What's the same, what's different? As I mentioned before, a cube has 1, 2, 3, 4, 5, 6, 7 and an 8th set vertex. Okay, it's got 8 vertices altogether. A cuboid has the exact same, okay, same number of vertices. It has 6 faces on a cube, and it also has 6 faces on a cuboid. Okay, same number of vertices, it's a fancy word for corners, and same number of faces. Okay, we can guarantee therefore it's got the same number of edges as well. Hopefully you figured that out. The only difference is that a cube is only a cube when all of those edges are the same length. You notice that every face looks like a perfect square. That's because it is. That means that all the faces are the same in terms of length, width, and therefore its height and depth, whatever you want to call it, are going to be the same as well. In other words, this shape is symmetrical. Everything is the same about it, no matter which way you look at it. Again, just think of a dice. It's the same no matter how you look at it, or just a perfectly cubic box. Whereas a cuboid looks like a very stretched out cube, doesn't it? Okay, and it's not just the length that's different, the width and the height can be different to each other as well. Think about cereal boxes. Each of these 3 dimensions would be different. The length would probably be the long be the longest measurement, the height might be next, or the width, who knows. But all three of these can be different. The only thing that it has to follow is its number of faces, edges, and vertices. They need to be the same as a cube. But again, just think of it as a stretched out version of that. So hopefully that's cleared it up a bit now. We know that a cube is a perfectly symmetrical 3D shape, whereas a cuboid is not. Alright? But they are similar in lots of ways. Think about this statement now. A cuboid is also a cube. Why don't you let us know in the comments whether that is always, sometimes, or never true. A cuboid is also a cube. Think carefully about that before you answer. Now, what you can do with a cube, in fact, what you can do with a lot of 3D shapes is you can actually form them with a net. Now, hopefully you might recognize that this net here can be folded to create the cube. We know that a cube has 6 faces. Therefore, this net, if it's going to form a cube, it should also have 6 faces. 1, 2, 3, 4, 5, 6. Brilliant, okay? And each of these faces are connected by at least one edge somewhere. Okay, you've got the one in the center here, which is connected on all 4 sides. But it's like unfolding a big cardboard box and flattening it out without cutting the edges too much. It's basically just this shape flattened out, and I'll show you here. You can go and find this video yourselves if you like. But here's our cube. It looks the same from every angle. You can see it's got different faces, it's got different colours, but you open it up and that forms what's called the net of the shape. The cube is brilliant because there's actually more than one net that forms a cube, like this one for example. Isn't that great? Look at that, okay? There's more than this as well. There's more possibilities in terms of forming a cube from a net of these squares here. So you can go ahead and have a look at that for yourself later on if you like. But the challenge we're setting for you guys with this presentation is here. You can find this on the class web page, you can print it off, but what we want you to do is to find out which of these nets can form a perfect cube. You can see all of them have the same number of squares, all flattened out, all connected in some way, but in a different way every single time. However, not all of these are going to form a cube if you fold them up, and it's up to you guys to actually draw these nets, cut them out of whatever piece of paper you've used, and see if you can form a cube where none of the faces overlap each other and there's no gaps missing. It needs to be a perfect cube, basically a perfect box once you fold it all together. For this you're going to need firstly a pencil and a ruler, probably a rubber just in case, and a pair of scissors. Alright? There's loads of resources you can find online to do this. You can make it as big as you like, but what you need really is some squared paper. If you can't get any squared paper, go back onto the class web page and find the dotted paper where you can use your ruler and your pencil to draw these nets between the dots. Okay, it's really simple, but make sure it's big enough for you to actually cut out and then be able to fold all of these nets to see which ones work and which ones don't for forming a cube. We'd love to know what you come up with, see if you get the same answers as your buddies, let us know. But again, if you have any problems, just get in touch with me. Alright guys, that's all for today. Good luck, hopefully see you soon.